Okay, so let's compare. Let's look for patterns. The question we really want to ask ourselves is what patterns do we see? What's the pattern between linear and exponential? What is the pattern that we see? Well, you're actually really good at noticing the pattern here. Every single time, there's no change. That's just going up. This right here is just going up by one every single time. But here, what's happening every single point, we have an increase. And that increase was plus 3, plus 3, plus 3, plus 3. Okay. So our pattern there is definitely a pattern of one, it's addition, and we're going up by the same number every single time. So that is a constant rate of change. Very, very constant. So over here, I would also write down the word constant. All right, write that word constant down. We have a constant rate of change, a constant rate of change. Okay, very constant. But let's compare here. Does anyone see a pattern when we go from 1 to 2, then from 2 to 4, then from 4 to 8, then from 8 to 16? What would that next number be? So really what I want you guys to look at is really what's actually happening here. So tell your neighbor, stop and tell your neighbor, what is that actual pattern that you see happening? So um, the pattern really happening here, if you don't see it, is we're multiplying by 2. Every single time we're doubling in size. So we're multiplying by 2. And that's the key there is when you see multiplication, that's going to be your tip off. That's your tip off that this is actually exponential and not linear. Here, you're going to see our pattern was purely a constant addition. We were adding every single time. But here, we're actually multiplying. So that's the main thing that we have to be able to compare is when it's multiplication, our pattern is exponential. When it's addition, our pattern is linear. That's the main takeaway from that particular part and really the most important part of today. So our last piece is to say, well, let's create a story problem for these two equations. So this one was 3x plus 2, and this one was y equals 1 times 2x, 2 to the x. So really what our word problems could be is maybe Miss Kendrick, she's going to start at 2. So Miss Kendrick has $2, but she's going to save $3 per week. That would be a linear function where we start with 2, that's our y-intercept plus 2, but she's saving $3 per week. Versus exponential, Miss Kendrick, I'm just going to call her Miss K, has $1. She's starting $1, but it doubles, right? Her $1 doubles every week. Okay, doubles per week. That's the difference in scenarios here that linear versus exponential, you have a constant growth where you're going up by $3 every week versus in exponential, her money was doubling every week. So that's our main takeaway. You're now going to look at some graphs and practice finding linear versus exponential.